Good afternoon and welcome to this Apteco Live 2025 focus group on your FastStats technical update. My name is Tim Heron and I'm the Connect team technical lead, and I've been with Apteco for 22 years. I'm going to be talking to you in this focus group about improvements that we've made to the FastStats Query Engine and to FastStats Designer during 2025. So in particular, I'm going to be talking about performance improvements to the query engine based around cube caching, the reintroduction of primary selectors and optimizations that we've been doing. I'm going to talk to you about variable usage and variable performance collection, and then I'm going to talk to you about the general performance in FastStats Designer. So at the end of Apteco Live 2024 last year, we had a focus group where I said that we've increased the text block size. So this has resulted in better compression for text variables and higher performance due to fewer I/O requests when processing text queries. But this was only part of the reason we did this. The main reason was that we wanted to introduce longer text fields in 2025. So in the 2025 Q1 release of FastStats Designer and FastStats, we've raised the limit from 255 bytes to 32K, so 120 times longer text fields. This only applies to text fields, it doesn't apply to selector codes or descriptions. FastStats Designer's auto-discovery process knows this increased limit for text fields, so in a change to previous behavior, if it detects that input data is longer than 255 bytes, but you only have a relatively few number of distinct values, Designer would have used to have kept this as a selector variable. It will now change it to be a text variable if auto-discovery is being used on that field. The idea of this text field is that as well as being able to do better sort of sentiment analysis and fully load your text strings, we also want to be able to load JSON or possibly even XML data into a FastStats text field and then use expressions to pluck out data items out of that JSON document or XML document, in a very similar way to that Postgres or SQL Server allow you to load a document as an nvarchar and then use expressions to pluck various bits out of it to use in your queries. So this would allow us to deal with unstructured or document style data within FastStats rather than having to normalize it out into tables and rows and columns to load it into FastStats. One big performance improvement that we've made to the query engine, we announced it last year that it was coming, is cube caching. So we've always had caching for selections and for the results of those selections, whether they are the count results or whether they are a selection bitmap to tell us which records are selected. Cube caching is now generally available. So it can be enabled from the Q2 2025 release onwards, and it's enabled by default from the Q3 2025 release. When you enable cube caching, we disable the Orbit database caching layer and just rely on this cube caching and selection caching at the query engine level. So we used to have a caching layer based around the job queue, which was okay, but it wasn't very powerful. It didn't support all of the cache object types that we could support at the query engine layer. And it also doesn't allow us to pre-process or refresh cache entries in advance. So one big advantage to the cube caching is that you can now refresh these cube cache entries when the service is idle or at the end of a build using the refresh cache post-load action in Designer. So this is designed to work around the issue of poor performance when the user first logs into Orbit. They open up a dashboard and none of the entries have been cached. Then the query engine has to go and calculate and process all of those cached entries. While if the cube entries have been pre-processed and pre-cached, then it means that either by the service or by Designer, then it means that when the user logs in first thing in the morning, then after a system rebuild, then all of those objects are pre-calculated and performance is very much better for displaying that dashboard. So let's have a quick demonstration of this in action. So I have a browser with Orbit inside it. Cube caching doesn't apply just to Orbit, it applies to Orbit, FastStats and Excelsior and PeopleStage as well. So all of the components which use a cube, those cubes can be cached to produce faster response. So I have 4 cubes on this dashboard. So I've got this cube at the customer level, so I've got 15 million customers, and I've got these cubes at the order level down here, and these are over 150 million also orders. And yes, you can see yes, 150 million. So let's refresh this page. So these entries have been pre-cached and pre-calculated, and although we've got to wait for the browser to refresh the page and the jobs to be submitted via the job queue, you should see that instead of having progress bars, these cube cache entries appear very quickly. If we take a look at the FS cache folder, so I've got these 4 cube cache entry files. So these are the new files which have been created by the cube cache process. The FSCF and MBM files were from the selection, so we're caching a selection on customers and we're caching a selection on orders, and then we've got various bitmaps to give us the results of those selections. If I were to go and delete these cube cache entry files and then go and refresh my dashboard, you can see that we've now got to go and do the work to actually go and calculate these cubes, and so we'll get the progress bars when these cubes start getting processed. So this top one has only got 15 million customers to work through, so that will be relatively quick. But you can see the progress bars on the orders cubes are taking a bit of time. And if I go back to my FS cache folder, you can see I've had a cube cache entry file appear. Now, every time we access and use a cube cache entry file or display a cube cache, this file will get updated, and that's because this file stores the hit count of the cache entry. So this gives us a way of identifying the cube cache entry files which are used most often or displayed most often, so that we can use them in our refresh process to refresh the most commonly used cube cache entry files first. So this is going to grind through these different cubes, so you can see a couple of these appear. It's worth noting that although the cube cache, we talk about cubes in FastStats underpin a lot of other object types. So as you can see, charts are part of the cube cache. Trees will be part of the cube cache as well as cubes. Even profiles are a type of cube. So once this final order status versus priority has finished, we should then see our 4 cube cache entries in our FS cache folder. So these are maintained with the same with the same cache maintenance logic that we use for the FastStats cache entry files and for the bitmaps. In general, they should be quite a bit smaller than for the selection ones because we don't have to store bitmaps. There's no corresponding equivalent to a bitmap for a cube. It's just the results of the cube stored in this file. So that's one big performance benefit, which will benefit your FastStats users and Excelsior users, but mainly your Orbit users because they create dashboards which have a lot of cubes on them, while generally with FastStats you're only looking at 1 cube at a time. Other performance improvements that we've made to the FastStats Query Engine is we've made improvements to the speed of the service startup if you have a large number of large partial indexes. So it used to be the case that we would have to checksum these FSDAT files which make up the partial indexes to verify that they match the system. We've made a rare change to our file formats. So we now put a header on these FSDAT files, the main FSDAT file and the partial FSDAT files, and this is a breaking change to our file formats for the 2025 Q2 release. This means that we can check that these partial indexes belong to the load of the date of the system much more quickly. We only have to check a few bytes rather than the entire file. And we've seen for one particular system where they have a very large system with 20 billion records and 10 partial indexes, that service startup was taking 15 minutes and it now starts up far more quickly. So with this breaking change to our file formats, it means that systems built with the FastStats Designer 2025 Q2 cannot be opened by earlier versions of FastStats. So this was never recommended, but you always used to be able to do it. And you will probably get an FSTAT wrong size error if you do try and open up these newer file formats with the earlier version of the software. Now we've got rid of this bottleneck with how fast the service starts up. We've increased the number of partial indexes up from 10 up to 255. So it's possible to create a covering set of partial indexes. So every possible partial index combination of tables can now be generated at load time. And create partial indexes post-load action designer can be done more efficiently if you're creating multiple indexes. So we can now create up to 10 indexes in parallel at a time. So if you're doing more than 10 indexes, you have to have multiple post-load actions, but it means that we do far fewer passes through the original FSTAT file to create the filtered partial index equivalent. We've also embarked on a major piece of work which will continue not just for this year but into next year as well, and these are query optimizations. So one way of thinking about how the FastStats Query Engine works is this great big if loop which works through every record in your system. And there are many if statements for the many different types of queries that you want to run. And those if statements are evaluated on every record. And this gives us a particularly big bottleneck. So the optimizations are where we have created specific tight loops for specific query types. So we identify what kind of query we're running up front, and we go and run a special optimized version of that loop which misses out most of the if statements that we don't need for that particular optimization method, and that can run very much faster. So at the moment we've got 3 levels of optimizations. We've got level 0 where we don't have any optimizations applied, level 1 where we have optimization functions just for some selections, and then level 2 where we have optimizations for selections and for cubes. So level 1 is available from the Q2 release, level 2 is available from the Q3 release, and in the Q4 release we've set the default up to level 1, and in the Q1 release coming next year we'll put the default level up to level 2, and then we're going to introduce level 3 to include RFV type selections. So expect to see more and more of these optimization methods added into the system. This can give a particularly good benefit. So we've seen and this is on our benchmark system, so performance improvements that you see will vary based upon your machine type, your disk speed, the FastStats system that you're doing, and also the selection criteria that you're using. But on our test system we see a 40% improvement for selector-based selections on single tables. We see a 30% improvement for selector-based selections involving a selector on a multi-table query. We see a 60% improvement on single table queries that use a numeric selection. We see a 50% improvement on begins with text queries on single tables, and a 25% speed improvement on other text comparisons for single tables. We've also revisited primary selectors. So primary selectors are a way of partitioning up your FastStats system so that we only have to look at a portion of the full FastStats system rather than the entire thing. So when we do a multi-table query, we only have to scan through a subset of all the tables rather than scanning through checking for records across all of the tables. So primary selectors have fallen out of use, and one of the reasons they've fallen out of use is that we haven't supported these with the enhanced build process, which is now the new default for new FastStats systems. We have introduced or reintroduced primary selectors into the enhanced build process. So it does an extra little sort at the start on your master table and then creates some extra files. It gives us a big performance benefit due to this partitioning, which I'll demonstrate to you in a moment. You can think of it a bit like a clustered index in SQL Server or other databases, where we're sorting the main master table in your FastStats system into the order of the primary selector. Once we've done that and we introduced the primary selector, we've done some extra work in the query engine to get primary selectors to work with, for example, partial indexes. So before, you would either choose to use the primary selector or you would choose to use the partial index. We can now work with both. So we could produce, for every partial index, we'll produce a filtered version of the primary selector, which allows us to uses partitioning with the partial index. So if your query can be used by a multi-table query, uses a partial index, and it uses a primary selector, it should go doubly fast rather than just relying on one of these mechanisms. And we've also made primary selectors work well with row filters, sometimes in our parlance called global filters. So if you're able to specify your row filter using a primary selector, and a classic example would be to restrict records the user can see based upon their country. If you could create a primary selector for the country and then specify the row filter with the primary selector, then the user would benefit from that global filter being processed using a primary selector rather than with a normal selector. So let's do a quick demonstration of a primary selector. So I'm going to use FastStats to do this instead of Orbit. So I have my TPCH system here. So I've got 15 million customers, 150 million orders, and 600 million order items. So I'm going to do a selection of orders based upon the nation. So I'm going to choose my customer nation, and this data is arranged so that it's been loaded with the primary selector, so it's sorted in order. So I can choose, for example, let's choose Canada. So we've got an Apteco office in Canada, and we've got an Apteco office in the UK. So when I run this count on orders, it's going to count out how many of those orders have been placed by customers in Canada and United Kingdom. But notice my count as I work through this. So it's going to do a count. So this is doing a multi-table query. And note it's counting 0 at the moment down here. Then it counts through my 6 million customers, and then it's counting a whole load of zeros. So the progress bar is going up, but no records are being added to my selection. And that's because it's counting through all of these countries which don't have any records in them, or don't have any relevant records in them. And then we get near to the end of the selection. I've selected United Kingdom, it's the second from last code. We should then start seeing this count increase again. So that count gives us our 12 million orders. So all the orders placed by people in Canada and all the orders placed by people in the United Kingdom. Now if I were to do the same selection with the primary selector, this means that my entire FastStats system has been sorted into this nation order. So I'm going to choose Canada again, and I'm going to choose United Kingdom. This isn't be cached, but it'll be so fast you'll think it is cached. Because it's not cached because I'm using a different variable than the duplicate one I did for C Nation. This is the C Nation primary selector. So now you'll see that it gets to skip all of these codes I've not selected. So I'm counting orders again, so let's run this, and you can see that this count goes up very quickly to count all 12 million. So that's the benefit of the primary selector. And any query which I can AND with my primary selector will benefit from this partitioning. So you can see how it can be particularly useful for row filters, where if you can specify your row filter to say, select my records using this primary selector, then we can just jump in and choose the correct records that we need, rather than have to work through all of the records that we don't care about selecting. So even if you have a really basic primary selector with just 2 codes in it, for example, you might have prospects and customers. If you can say all your selections, and I want to only consider my customers, or I want to consider just my prospects, then that can almost halve the size of the data volume that you're working with. And in this, for example, if you had a system where you had, say, 30 million prospects and 1 million customers, then you could load everything into the FastStats system. And if your selection primary selector would say, okay, I only want to see my customers, then we'd only be running queries over the 1 million records rather than the 31 million that we normally do. Now, one thing that we're keen on is collecting telemetry to see how these optimizations and performance improvements behave in the real world. So we can test these against our benchmark system, but it doesn't really give us a clear picture of what's going on in your systems. So we've added 2 new tables to the Web Service Control database, and these are on by default from the Q3 release in 2025. we collect the job queue stats table, and this is the one which is probably most useful to you because it records which variables are used in a query and how those variables are used, whether they're used in a cube or a profile or a selection. And that the idea is that we will be able to use this in conjunction with the variable scanner to give you a better appreciation of how variables in your system are being used. And the other table is the job queue performance, which will record performance metrics about a query. So how much CPU, how much disk I/O, was the result cached, was a partial index used, was an optimization used. And the idea is that the job queue performance will be sent back, it's not at the moment, but will be sent back to our telemetry service so that we can get a good idea from real world systems which optimizations are being used, which systems are using primary partial indexes, where primary selectors are being used, so that we can use this to guide our development in the future. So let's have a quick demonstration of that. So if I go and take a look in my and update my SQL tables, look at my two tables. So I've got this table up here of job queue performance. So you can see here that we ran just now in FastStats, we ran a multi-table single selector query and then one with the primary selector. So we have optimized functions for those. So as well as benefiting the primary selector, those queries were ran with an optimized function. We can see the CPU usage. You can see it was far greater for the non-primary selector one compared to the primary selector one. And then we looked at the disk reads and disk writes and gave a total of the amount of work that we had to do. So this table will grow up in time. And so this is what we will try and analyze through our telemetry service to try and improve the performance of FastStats in the future. The other thing which maybe is more useful to you, can see I did these selections based upon customer nation primary selector. So these were used in the query where I had the base query and I selected a couple of codes. So that these variables were referred to within my query XML 3 times effectively. But it gives you an idea, so you can see that we end up with multiple variables per job. So you can see here for these jobs, it's order priority and order status, that was a cube. And those both related to that single job, and you see those variables were used in a cube, while these other ones were just used in a selection query. So this can be used to give you a better idea of how variables are being used. So you can just go and run a SQL query to work out when was a variable used, and then you can join your job queue job ID to your job queue to see which user that was running that particular job. So we do have the variable scanner, which gives up a lot of the similar information, but there's a bit more information in here, and this is up to date in real time. So if you want to go and see, without the variable scanner can take quite a while to run, it analyzes the job queue. If you want to go and see, okay, were any of these variables used yesterday, you can go and just run a query against this table in SQL, and then if you want to dig down into it more, you can build a system using the conventional variable scanner process. So that's the performance stuff I wanted to work through with the FastStats service. Now I want to talk to you about FastStats Designer and the improvements that we've made to that. So in the 2025 Q1 release, we've added support for the DuckDB ADO.NET provider. So this allows us to use the open source in-memory database DuckDB, which is a very good database for gluing other things together. It's used in a lot of ETL tools to do that kind of processing. So through DuckDB we can now directly read JSON and compressed JSON files and Apache Parquet files. We can also actually use DuckDB to query directly from Azure Blob Storage and S3 buckets and other mechanisms. So DuckDB does the authentication, downloads the file, queries the file, and so Designer doesn't have to do that. We can now generate partial indexes in parallel in our post-redaction, up to 10 at a time, to make generating those indexes faster. We introduced the int64 and the GUID join key types in the Q4 release last year. We've now, in the Q1 release, introduced the unsigned int join key type, which allows you to have integer keys up to 4.3 billion, so from 0 to 4.3 billion. And we've introduced this because previously we only had int key types, which were plus or minus 2.1 billion. and not many people had negative keys. So the int and the uint keys, because these are 4-byte keys, we don't have to use hash tables to do these. We can just create a great big map in memory, a 16 gigabyte memory map file, and it makes using these keys significantly faster than other key types. So if you're building very big systems, you should really try and use uint or integer keys. And we've introduced long text fields as well. In the Q2 release, we added the option to specify your Salesforce API number. So the Salesforce API is versioned. So if you are connecting to version 50, you know that you get version 50 of their data model, the tables and fields which apply to version 50. But every quarter they move on to a new version. You can now enter that API number into your Salesforce credential, so that if you want to stick to a particular data model or you want to always have the latest one, you can choose that in your Salesforce credential. We've improved the unclassified decode options. So before you could always specify the description of your unclassified code. Now you can also specify the code as well. It can't be blank, it always has to be something, but before it was always an exclamation mark. Now you can choose whatever it is. Remember, the most important thing is that the unclassified code appears as the first code in the list. It's not that it's an exclamation mark. We also support time zone conversion for date time fields when you're performing an extract from a database. So it used to be the case that your database was almost certainly always in the same time zone, or at least in the same building or data center as your FastStats build machine. Now it's quite common to have data in Azure SQL where everything is stored in UTC format. So the SQL Server which runs Azure SQL is set to UTC, and your build might be in a data center in Ireland, and then you're deploying to your server in Frankfurt, or you're building in Frankfurt and deploying to a data center in Ireland. That's very common. So you can now specify a time zone when you're downloading, and so you can specify it so it makes sense to your users, so you can put your date times into the user's time zone during the extract and build process. We've reintroduced primary selectors for the enhanced build and changed the file format, the FSDAT files. I've covered those 2 points already. In the Q3 release, we didn't do very much. We just, in the enhanced build process, we now support single-digit fields in dates. So if you have D/M/Y as your date format, for example, you might get that as a very common as the default Excel date format. We can now load that. Previously, we always had to have a leading 0, so it had to be 0D/0M or so on. Obviously, you can't do that with a fixed format date field because you've got a leading 0 anyway. So if it's DD/MM/YY/YY, then you've still got to have the leading 0 for the day and the month and the 2000 for the year. We can strip off leading and trailing currency characters. So if you specify a field to say this is a currency field or numeric field, and you've got leading or trailing currency characters, they can be stripped off. And also, finally, for float and double numeric types, we support the scientific numeric format, so with the E notation. So you have the mantissa and the exponent specified together for your binary, float and double types. I remind you should avoid using binary floating point types for currency values because they are only ever approximate and they are not exact. You should be using a decimal type for currency values. Finally, in the 2024-5 Q4 release, we've made some improvements to dynamic data sources. So you can now specify nested folders in dynamic sources, and also you don't have to re-extract them every single time. Previously you had to re-extract every single time you did a build if you were developing the build. This made it quite slow to develop a build with dynamic sources. Now you can just reuse the files which are on disk. We've extended our OAuth credentials so that they can be used in other credentials. So we supported OAuth credentials for Salesforce, and then we introduced it for directly in Salesforce, and then we introduced it so that if you're doing a connection string to Snowflake, you can do an OAuth credential for that. But we've made this much more generic now, so that when you create an OAuth credential, you can choose the 2 types, either an authorization flow or a client credentials flow, and then you can use that to either populate an environment variable to specify an access token in your database, or you can use that as authentication to Salesforce, or you can use it for authentication to SMTP. And this is particularly important because we're seeing various services start to deprecate older forms of authentication. So the Office 365 SMTP service will next year deprecate basic authentication, and they will require you to either use GraphQL or OAuth v2. So we now support OAuth v2 for SMTP credentials, and I'll give you a demonstration of OAuth v2 in a moment. So this is it's being put into Designer, and in the 2026 Q1 release it will be put into the FastStats service, so that the emails which get sent for password resets or registration emails, those kinds of housekeeping emails, or the emails that get sent by Designer to tell you that a build is finished or a build has failed, so non-email broadcasting emails, they can get sent through an SMTP service which requires OAuth v2 authentication, or we still support the basic authentication as well. In a similar vein, we now support the Microsoft Data.SQL client plugin for both for FastStats Designer, and we've migrated the entire FastStats service and the Apteco management suite, Apteco marketing suite, to use Microsoft Data.SQL client plugin. This allows a modern authentication using Microsoft Entra. So if you want to authenticate using OAuth client credentials, you can now do that using this this plugin in your connection strings, rather than the older system.data.SQL client, which didn't support these modern authentication types. So FastStats Designer OAuth v2. This allows you to authenticate with an OAuth v2 provider, and that creates a long-term OAuth credential. So either that is if you use an authorization flow, that will create a refresh token, or it will create, if you use client credentials flow, you'll have a client ID and a client secret, and that can be used to create an access token. That access token is then used to access the resource that you want to. So that access token can either be substituted into a connection string via an environment variable, or if it's something like an SMTP Salesforce or connection, then they know about the OAuth authentication mechanism and can use that in Designer. So let's have a quick demonstration of that. So I've got a example design in FastStats Designer here, and I've got 3 credentials. I have a Salesforce credential, and I've got 2 OAuth credentials. So I'm going to demonstrate both of these. So I have my Salesforce client credentials here, and so I have my client ID, and then I have a client secret, which I'll try not to reveal to you, even though it's just a test one. And I can click test, and that will go and use these credentials to authenticate to Salesforce's OAuth provider. Now I could be authenticating to Salesforce's OAuth provider, or it could be authenticating to Microsoft Entra or to Snowflake's OAuth provider, or a mixture. I could use authenticate to Microsoft Entra, and then if my Snowflake is configured to use Microsoft Entra, that would allow me access to Snowflake. So I've set up this OAuth client credentials credential. In my Salesforce, I've got my old-fashioned OAuth token directly, username and password, but now I can specify my OAuth client credential here. I can choose my client credential, and all these options are grayed out, and then I can go and test that I can go and connect to Salesforce using my OAuth client credential. The other flow which is possible is the authorization code flow, sometimes called the website flow. This is where you specify a URL and a redirect URI. So here I have a refresh token. I'm going to delete this. So I'm going to go through a process to get a new refresh token. So if I click get refresh token, 2 things will happen. Designer will start up a little mini web browser, sorry, a little mini web server, which is listening on port HTTP localhost 5000, and it will also launch a web browser. In this case, my default web browser on this machine is Chrome. So it will launch Chrome, and it will take me to authenticate to Salesforce. So here we go. I've got my Salesforce URL up at the top here. I've got my credentials, so I can log in. It says authorization successful. You may close this tab. Notice that it's been redirected to the little local web server on the FastStats Designer machine. So Designer has captured that refresh token, and I can then test that this refresh token is valid. So this refresh token, if it's not used, it will be valid for up to, I think, 90 days. That's configurable based upon your OAuth provider. However, if you do use it repeatedly, then it will stay valid, unless an administrator on your OAuth provider decides to expire refresh tokens. So I can now use this refresh token effectively as a password. I'll go to my Salesforce and choose I want to use my OAuth. So that's the credential I've just created. I can click Test Credentials. It will use a refresh token to go and get an access token and then make an API call. So all that remains for me to say is to say thank you very much for listening.